Now we look at example 1. A closed can in the shape of a right circular cylinder of radius r meter and the height h meter has a volume of 16 meter cube. So first express the surface area A in terms of r. So second, B, find the radius of the can so that the total surface area shall be a minimum. So like I said before, so our can is in the shape of cylinder and radius r meter and height of h meter. So first the question is express the surface area A in terms of r. So the area of the cylinder will be, so you have to memorize 2 pi r squared plus 2 pi RH. So this is the area of the cylinder. But on the same time, if you still remember, in our first step, develop the function with one single variable. So you can see that in this example, in our first step, the area have two variables. One is r, radius, another one is h. Means that we need to replace the h. Why? Because you can look at A, express the first surface area A in terms of r. So in terms of r. So h have to be replaced. So next, how are we going to replace? By using the information given. You can see that volume is 16 meter cube. So the volume of the cylinder is 2 pi, oh no, the volume of the cylinder is pi r squared h, where the volume now is 16, which means that pi r squared h is equals to 16. H is equals to 16 over pi r squared. So let's say if here is first equation and this is the second equation, so I will substitute the first equation and the second equation. I will substitute the second equation into the first equation. So now our area will become 2 pi r squared plus 2 pi r h. Our h is 16 over pi r squared. So here we can simplify. Let's say I try to simplify. Pi cancel out with pi. This is r, so we cancel out with r. So from here, our area will be equals to 2 pi r squared plus 2 times 16 will be equals to 32 r. So 32 r. So this is the answer for A. Area in term of r. So this is area in term of r. Next, B. Find the radius of the can so that the total surface area shall be a minimum. So this is the first step actually. A is the first step. Express. So if you still remember, so let's say develop the function with one single variable. So here from A, we already developed the function with one single variable, which is r. So in our second step, find the first derivative. So in order to solve for B, next, B, we will find the first derivative. Let's say A is equal to 2 pi r squared plus 32 r power of -1 because I want to differentiate. So next, I will differentiate dA over dr. So here is 4 pi r. So here multiply, if you do this one, multiply or bring the index front -1. Same go to here, bring the index to the front and then reduce by 1. So from here, I should have -2 32 r power of negative 2. Or I can write in the form of 4 pi r minus 32 over r squared. So in our next step, I will let dA over dr equals to 0. So you can see, next step, let the first derivative equals to 0 and solve for x. So in this example, so let the first derivative equals to 0. So in this example, we will let the first derivative equals to 0 and solve for, this is not x, but solve for r. So next step, 4 pi r minus 32 over r squared supposed to be equals to 0. So 4 pi r will be equals to 32 over r squared. Multiply r squared to the left hand side. 4 pi r cubed is equals to 32. Or finally, r cubed will be equals to 32 over 4 pi. So r will be equals to the third root of 32 over 4 pi, or equals to, we can use our calculator. So 32 over 4 pi. 32 over 4 pi. So this is 2.929. So here is meter. So here is the radius. So this is the, let's say, so here is the third step. Let the first derivative equals to 0 and solve for x. Next, we will find the second derivative. Also known as second derivative test. So next, I try to find, again, this is my first derivative, 4 pi r minus 32 pi r squared. So let's say, I just write down here, dA dr is equals to, let's say here is 4 pi r 32. So it's 4 pi r minus 32 r power of negative 2. So this is the first derivative. Now we come to the second derivative. So second derivative of a with respect to x will be equals to 4 pi. So again, multiply or bring the index up front and reduce the index by 1. So here will become positive. So 32 times 2 will become 64 r power of negative 3. Or I can write in the form of 4 pi plus 64 over r cubed. So next step, substitute the value of x or r into the second derivative. So if the second derivative is positive or greater than 0, then x is a minimum value. If the second derivative is less than 0, then x is a maximum value. So next we will substitute the value into the second derivative. So now our r, when the value of r is equals to 2.929 meter. So our second derivative of a with respect to x will be equals to 4 pi plus 64 over 2.929 power of 3. So means that 64. So let's calculate over 2.929 power of 3. 2.929 power of 3 plus 4 pi. So here is 15.11, which is greater than 0. So if greater than 0, then r is a minimum value. So from here I can make the conclusion. Therefore, R is equals to 2.929 meter is a minimum value. So the question, find the radius of the can so that the total surface area shall be minimum. So here is the answer. We only need to find the value of R.